Hi everyone. We're going to determine algebraically if the following functions are either even, odd, or neither. So basically the formula we're going to use, or the test, is we're going to check for f of negative x. If we get back the original function, it's even. If we get the negative of the original function, then it's odd. For example, for this one right here, if I plug in negative x into my x, this gives me back my original function, so it's even, because you're squaring out the negative. And even function is symmetric about the y-axis. So that means you can fold it on the y and it should match up. The odd function would be this one right here. So when I plug in y equals negative x cubed, this is the test, I get y equals negative x cubed. So this follows this definition, and it's an odd function. An odd function is symmetric about the origin. So it goes through the origin, but it basically does two. Like I say, it flips over the x, and then it also flips over the y. Or you could say, well, it flips over the y, then it flips down over the x. So it's kind of like two flips on that. Anyway, we're not going to do graphing on this. This is determining whether the functions are even, odd, or neither with no calculator. So I have about 6 problems. Here's the first one. The first thing we're going to do is take the test and find out what is f of negative x. I want to know an even function is going to look like the original. So the even function will look the same. It'll be x squared over x to the 4th minus 3. However, on the odd function, if it's odd, it means f of negative x equals negative f of x. So that means when I'm taking this, what it would look like odd would be you're multiplying x squared over x to the 4th minus 3. You're multiplying it by negative 1. So that's negative 1 over 1. So you negate the numerator, but not the denominator. Or we can negate the denominator but not the numerator. So in this case, it would be negative x to the 4th minus 3, which equals x squared over negative x to the 4th plus 3. Sorry, plus 3. I have to move this over. So let me erase this and move it up a little. So simplified, this would be x squared over negative x to the 4th plus 3. It's a negative. So these would be if it's odd. All right, even will look just the same as it did before. So let's do the test. So everywhere there's an x, I'm going to put parentheses. I'll just do it this way. And you're going to plug in negative x. Okay, and what we get is x squared on the top, and the denominator is x to the 4th minus 3. So f of negative x equals f of x. It goes back to it looks just like my original equation, so it is even. Okay, the next ones I do, I'm going to go a little bit faster. All right, here we have f of x equals x over x squared plus 2. So basically, if it's even, it looks the same. So negative x would equal x over x squared plus 2. That's what it would be even. Odd, you either negate the numerator, so f of negative x would equal negative x over x squared plus 2, or x, and you negate the denominator, that's negative x squared minus 2. Okay, so now let's do the test. Everywhere there's an x, I put negative x. So what I get is negative x over x squared plus 2. Well, it doesn't look like my even, so it's not even. Does it look like one of these two? Yes, it does look like this one here. So my answer is this is an odd function. Okay, the next one, we have, if it's even, it's just going to be the same function. So when I plug in negative x, I should get x squared over x plus 2. If it's odd, so odd, when I plug in negative x, I should get either negative x squared over x plus 2, or I should get x squared over negative x minus 2. So let's do the test and plug in negative x, and we get negative x squared over negative x plus 2. This yields x squared over negative x plus 2. Now, it doesn't look like my even, so it's not even. Does it look like this one? No. It doesn't look like this one? No. So this one is neither. And the next one, if it's even, it looks the same as the original function, which would be x cubed over x squared plus 3. If it's, so this would be even. If it's odd, you either negate the numerator, but not the denominator, or you negate the denominator, but not the numerator. Let's do the test. So f of negative x equals negative x cubed, and everywhere there's an x, you put negative x, and we get negative x cubed over x squared plus 3. Well, it definitely doesn't look like the original function. Oh, it does look like this one right here. So this function is odd. It means it's symmetric about the origin. Okay, and two more. I'm going to go ahead and just do the test. In negative x over negative x squared plus 3, which yields negative x over x squared plus 3. Obviously, it's not even. If it's odd, then we negate the numerator and not the denominator when you test for negative x. And that's what we have. So this is an odd function. And one more. What do you think this one is? Let's just plug in negative x. Everywhere there's an x, you square negative, it turns positive. It looks just like the original function, so this would be even. Okay, it's very simple. The ones you have to be concerned with are those odd functions. Thank you and have a nice day. Bye-bye.